Objective 9.2, Graphing Simple Rational Functions. In this objective, we want to be able to identify the horizontal and vertical asymptotes for the graph of a simple rational function. Now, simple here simply means that these are some of the more basic forms that rational functions can take. So we'll start with simple rational functions today, and then we'll move on to more complex looking rational functions in the next objective. So we want to be able to identify horizontal and vertical asymptotes. Then we want to be able to graph simple rational functions using transformations, and we want to be able to state the domain and range of the rational function. So first of all, let's make sure we understand what a rational function is. It is simply a function set up as a fraction where both the numerator and the denominator are some sort of polynomial, and the denominator cannot equal 0. Now, the polynomials can be as simple as a number or as complicated as x squared plus 3x minus 2. It just depends on what's happening in the problem. So let's start with the parent function. This is the most basic form of a rational function, and it is the function 1 over x. Take a moment, pause the video if you need to, and go ahead and fill in the values table that is in your guided note sheet for the x values that are given to you. When you filled in the table, go ahead and start the video again to continue. Alright, so what you find is that for each x value, we're really just taking the reciprocal of that value. And notice that when we use an x value of 0, that would give us 1 over 0, which is an undefined value. Okay, so we don't actually get a value for this y. Okay, that's going to be important here in just a few seconds. But we can get the rest of the values, and so now we can plot the points. So go ahead and take a minute on your own sheet to plot the points that you've just discovered in your table, and then you can come back and check that you have your points in the right place. Okay, so here's what your points should look like. Check them on your own paper to make sure you have them in the right place. So there's our negative x values. Notice we've skipped over the x equal to 0, which is the y-axis, and now we have our positive x values. Okay, and so now with those points in place, we can draw our curve. But remember, at x equals 0, which is the y-axis, we have an undefined value. So when we draw our curves, we have to make sure we draw them in such a way that they do not touch or cross this y-axis. Okay, because there's no way that we can have an x of 0 in the denominator. Because of that, because this line now sort of becomes an invisible barrier between two different sections of our graph, these two sections are what's called a hyperbola. So the shape of this graph with the two separate curves is called a hyperbola, and this invisible barrier between those two curves is what we call a vertical asymptote. So our y-axis in this case is serving as a vertical asymptote, and our graph cannot touch or cross that asymptote. Okay, and that's all due to the fact that if x equals 0, we get an undefined value. Now what about y being 0? Is it possible to choose a value for x in which our answer, the y value, would actually end up being 0? Well, the answer is no, and so that means our y equals 0 line, which is the x-axis, is also an asymptote, an invisible barrier, and it's a horizontal asymptote. So in a sense, these two axes in this case, which form our vertical and horizontal asymptotes, divide our graph up into 4 sections. And our actual graph then ends up in 2 corners of those 4 sections. So let's just take a closer look at some of the characteristics of a rational graph, especially in terms of the parent function that we just graphed. So we just mentioned the shape is a hyperbola. The vertical asymptote is the y-axis, or x equals 0 line. The horizontal asymptote is the x-axis, or the y equals 0 line. That means that the domain is going to be all numbers except wherever the asymptote is. So wherever the vertical asymptote is, that value of x cannot be in our domain. So one way to say that is all real non-zero numbers, or an easier way to do that is to just say x is not equal to 0. Similarly with the range, we can have any number except for the value where our horizontal asymptote is. So in this case, that's going to be 0, so y cannot equal 0 for the range as well. Now, from that parent form, we can get the transformation form, where we include the a, h, and k values in order to move or reshape our graph. Excuse me. The function of a, h, and k is still the same as it has been in any other function that we've dealt with. If a is negative, then that tells us we have a reflection through the x-axis. If the absolute value of a is bigger than 1, then we should be seeing a vertical stretch in our graph, whereas if the absolute value of a is between 0 and 1, sorry, not 0, 0 and 1, then we should be seeing a vertical shrink. The h value still moves our graph to the left or the right, and our k value still moves the graph up or down. So if we compare characteristics now between the parent function and the transformation form, our shape is still going to be a hyperbola. The vertical asymptote now is going to depend on whatever our h value is. If the vertical asymptote is normally at x equals 0, our h value not only moves every point of the graph, but it also moves this vertical asymptote. So our vertical asymptote in the transformation form will always be x equals h. Similarly, the horizontal asymptote will always depend on our k value. Again, the k moving the graph up and down means it's also going to move the horizontal asymptote up or down. So our horizontal asymptote will always be at y equals k in this transformation form. Which means then our domain is going to be x not equal to h, and our range will be y not equal to k. Because if that's where the asymptotes are, those are values we cannot have. Alright, so actual steps for graphing. Your first step is to decide where the vertical asymptote is. Even when we get into the more complex forms, this is going to be your first step. Excuse me, guys. The second step will be to figure out where your horizontal asymptote should go. Next, you'll want to plot at least 2 points on each side of the vertical asymptote.
Sorry, did I leave a binder here?
I don't think so. And number 4, draw the curves of the hyperbola, or what we would call corner huggers. So let's see an example of this. We want to graph this function and then state the domain and the range. So our function is f of x equals 3 over x minus 1 plus 2. First, we're going to start by looking for our vertical asymptote. In this case, our h value is 1. Okay, right here. and so our vertical asymptote is going to be at x equals 1. When we draw that, it's going to put our asymptote right there. Next, we look for our horizontal asymptote, which is going to be based on our k value. So since k is 2, the horizontal asymptote is y equals 2, and that's going to be graphed right there. Now, once you have these asymptotes in place, then you can set up a table of values. We're going to start by choosing two x values that are to the left of my vertical asymptote. So since the vertical asymptote is at 1, I'm going to choose values of 0 and -1 for my x. Putting in -1 for x gives me an answer of 0.5 or 1/2. Putting in 0 for x gives me an answer of -1. And so I plot those 2 points on my graph. Next, I'm going to choose two values that are to the right of my vertical asymptote. So I'm going to choose 2 and 3 for x values. Again, substituting those into my function. When x is 2, y is going to be 5. And when x is 3, y is going to be 3.5. And so now I plot those 2 points. These points tell me which corners my corner huggers or my curves will need to go into. So having 2 points down here and 2 points up here tell me that these are the 2 corners that my curve should go into. And so now I can draw those curves. And then for domain and range, we again go back to our h and our k, and we simply say x is not equal to the +1, since that's where the vertical asymptote was, and y is not equal to 2, since that's where our horizontal asymptote was. Alright, so why don't you take a moment to try a problem on your own. Pause the video while you work this out on your graph. Make sure you remember to state the domain and range, and then when you're ready to check, begin the video again. Alright, so our function -2 over x plus 3 minus 1 should look something like this. Our vertical asymptote is at x equals -3. Our horizontal asymptote should be at y equals -1. Putting in values of x that are to the left and to the right of our vertical asymptote gives us points that we can graph. And then using those points, we can tell where our curve should go. And from our horizontal and vertical asymptotes, we can come up with domain and range. The domain is x not equal to -3, and the range is y not equal to -1. Now there's one more form of the rational function that we want to look at today, and that is the form where we have ax plus b over cx plus d. So basically we're looking at a rational function where we have a linear in both the numerator and the denominator. In this form, the vertical asymptote will be whatever value of x that makes the denominator equal 0. And the horizontal asymptote will be y equal to the a over c. So the coefficient of the x from the numerator and the denominator will create a fraction that will give us our horizontal asymptote. Alright, so let's take a look at an example of this. In this case, for our vertical asymptote, we want to take our denominator and set it equal to 0, and then solve that equation. So I add the 4 to both sides, divide both sides by 2, and I get x equals 2 as my vertical asymptote. For the horizontal asymptote, I need to take the a over c. So in this case, technically my a is 1, and so when I take a over c, I'm really taking 1 over 2, so y equals 1/2 is my horizontal asymptote. So on my graph, I'm going to graph x equals 2 as my vertical asymptote, and y equals 1/2 as my horizontal asymptote. Now I can choose some x values to the left of my asymptote. So I chose positive 1, which gives me negative 1/2, and negative 1, which gives me 0. So those points are going to go right here. And then choose a couple of points to the right of my vertical asymptote. Those will give me values of 2 and 1. And those points will go right here. So now I know which corners my curve should go in, and I get a graph that looks something like this. Again, for domain and range, we're simply going to go back to the vertical and horizontal asymptotes, and we're going to state that x cannot be equal to 2 and y cannot be equal to 1/2. Alright, so that should give you the information you need for the 9.2 practice. Sorry for all the coughing during this, but I hope it didn't interrupt the information that you needed to learn. If you do have any questions over any of this, please make sure you ask during class. And when you finish Objective 9.2, please be sure to show it to me so I can check it off your list. We'll see you next class.